or evaluate the service from the different perspective. That means different perspective in the sense is what? So if you are going to have the service of CPU, that means you are going to access the CPU. Then if you are going to have the access to the CPU, what technology I have to use of, and what configuration of system I should have. So that you should know. So I'm going to see that particular service in a different perspective. So when you talk about your functional and non-functional attributes, so functional attributes are nothing but what? Your infrastructure. So that means without those things, your system will not work. Okay. So that is, it requires CPU, it requires internet connection, and it requires keyboard to type in, to which is to which web interface you have to log in. So those things you have to keep in mind. So that is that, but it identifies what? It identifies a set of functional and non-functional attributes, and it will be used to evaluate the behavior of a service from different perspective. Okay. So now these could be the performance attributes. So these are the performance metrics such as response time or security attributes, transactional integrity, reliability, scalability, and availability. So as you told that the different security attributes are there because whenever you are accessing the system from the distance place, so that has to be nobody should access those systems in transit. That means when you are accessing the system from different place to your system, so in between some other person should not come and he should not access your information. So now the transactional, for that particular reason, you should have the transactional integrity. So the transactional integrity is nothing but what? So as you have been studied in your database, I think, right? So that is in the integrity has to be there. Uh, so you have to follow. So this should be, it should also be scalable. Scalable in the sense is what? If my processor has been increased, that the processing, more processing speed has came into the existence in the market, what I should do? If more scaling, the more higher version of the processing has came, so what I need to do without without giving the problem to the user, the other side has to increase that one, increase the speed of that one. That is seamlessly it has to do. That means if I am going to have the 1 gigahertz using, so in the market my 2.5 gigahertz or 3 gigahertz system will come. Now I want to upgrade to the 3.3 gigahertz speed, but if I want to upgrade it, what I need to do, I have to stop giving service to the user. But what is the requirement I should have? I should have a requirement that I should not stop the service. Without stopping the service, I should give access to the other user. So that is what the scalability is there. Then is this availability. So availability is the sense is whatever you are going to have, you are going, it is should be available for 24/7. Okay. So for that particular reason, what has been invented? So for that particular reason, the concept of software as a service has been introduced. So your software as a service is nothing but the new delivery model for application. So that is what the service oriented computing is been done. So it is introduced and diffuses two important concepts. The two important concepts are your quality of service and your software as a service. So next, so any doubt with respect to the service oriented computing? Anybody having any doubt? Any doubt? If you have any doubt, you can ask. So if you don't have any doubt, we will move further. So next is service oriented computing in web interfaces. So how we are providing a service oriented architecture in web interface. So when you're talking about your service oriented architecture in web services, so what is web services? You're going to have web services are nothing but the software components. So that exposes the accessible using the method invocation pattern that goes over the hyperthread transfer protocol. So that means with the help of the web service, they are nothing but the software components. So whatever the web service or whatever the thing you are going to use to develop the application, that is also nothing but the software services. using this pattern, what I have to expose, I have to expose the functionality in such a way that using this particular features, I want to access the different infrastructure. That is, I'm going to make use of the web. If you are going through the web, then you are going to make use of which protocol? HTTP protocol. That is your hypertext transfer protocol. That you have to use it. So once by using that one, so you can access the different functionality of the web interface. So now, whenever you are going to have the interface, so the interface of the web service can be programmatically inferred. How it will be inferred? By metadata. So metadata is nothing but what? So it is data inside the data. So it can be programmatically inferred by metadata. How it will be incorporated? That one, the metadata will be incorporated through the web service description language. The metadata will be incorporated using what? Using the service description language. Now, why you are going to have? So the XML language which you are going to have is now WSM is a STL is a XML language, that is extended markup language. So that defines what? That defines the characteristics of the service. That defines the characteristics of the service and all the methods. So here the methods refers to what? The method refers to the functions. So together with some of the parameters, return type and exposed by the service. So your WDSL is an XML language where you are going to write the code and what it is going to have, what it is going to determine or it is going to define. So it is going to define the characteristics of the service. So what is the service you are going to give and what are the different services methods you are going to provide and what is the return type of that particular method. So it should be determined by your WSDL, that is your XML language, what you are going to have. Okay. So that is about your service-oriented architecture. So the next comes your utility-oriented computing. When it comes to the utility-oriented computing, what it provides. So now it defines the service or provisioning model. So utility, as the name indicate. So utility means what? To run a program, what are the things you require? Okay. So what you require. So here, so what you require? So it is a vision of computing that defines the service provisioning model. For what model you are going to have that one. So in which such as storage, compute power, applications, and infrastructure. So they are all packed together and offered on a usage. That means utility computing is nothing but what? So it is a so that depends on service providing model. So what services you are going to give for computing services in which the services resources such as your storage you are going to provide as a utility, computing power you are going to give it as a service, applications you are going to provide the service, and infrastructure you are going to provide as a service. And these services which you are going to provide or these resources which you are going to provide, on what basis you are going to provide? You are going to provide as per the usage. That means I want that particular system, this resources to be there with me for 10 days. So then you can pay the rent for 10 days and you can use it. So now if you don't want if you want any applications to run for 20 days, then you can take that 20 days and you can use it. So that is what your utility computing is all about. So now if you have the application and system deployment perspective, from an application and system development perspective, so your service oriented computing and service oriented architecture, which we have discussed already, what it introduced the idea of external services for performing a specific task. What it gave? It gave an idea that so it has to take the external services. Why we have to take the external services? We have to take the external services to do a specific task with a software system. Okay. So now when you are taking the service, to perform a specific task within a computer system, that we are using it on pay-per-use basis. So if a service-oriented computing introduces and diffuses two important concepts. That is, one is what the application what not only distributed. So that means whatever the applications you are going to use, it will be standalone. So they started to be composed as a mesh of services. They started to be used as a mesh of services provided by different entities. Okay. So next, these services, whatever you are going to have, it will be accessed through the internet and were made available by charging according to the usage. So service-oriented computing introduces and diffuses two important concepts. What are they? The application are not distributed is one, and they are going to give you the mesh of services. Mesh means what? The one service is connected with interconnected with the other service. Okay. So with the help of what? With the help of the different provided by different entities, it is going to access. Now, whatever the service you are going to give, so these services will be accessible through the internet. So when you are accessing through the internet, how they are made? They are made available by charging according to the usage. And they were made available by charging according to the usage. Now here you can see that not only your computer power and storage are accessed, even the application components could be utilized and integrated on demand. Okay. So if you take, we are already stated that you are going to access your compute power and storage and even networking, and you are going to use those resources as per the usage. Apart from that one, you can also use the application components. So that means if you want to have like that CRM I told, ERP I told, that is customer relationship management or enterprise resource planning could be there, and application components are there. Even these components could be utilized and integrated. So these components can be integrated and integrated and utilized on demand. Okay. So next, how to build a cloud computing environment is the next question. So once we gone with the service oriented computing and utility over computing. So these are nothing but what? So you are going to provide the resources of the system, that is nothing but your compute power and storage on pay per usage. Okay. So now once you've done that one, how to build the cloud computing environment, how I have to build that particular environment in my system. So this is the next question. Okay. So before going further, so anybody having any doubt with respect to the utility computing and service oriented computing? Anybody having any doubt with respect to utility computing and service oriented computing? Anybody having any doubt? So it should be interactive. So if it's not interactive, then it is of no use. Okay. So if you have any doubt, or if you feel to ask any questions, you are feel free to ask. Don't simply quiet. Please sit and listen. Anybody having any doubt? Okay.
No.
So if you don't have any doubt, let us move further. How to build the cloud computing environment? If I want to build the cloud computing environment, what you should have? So I have to develop the application first. If I want to develop the cloud computing environment, as we have seen the basic architecture of cloud computing, so all the resources will be accessed through the Web 2.0. So if it is accessing through the Web 2.0, what do you require? So it has to develop the applications. And whatever the system you are going to have, that will be used cloud computing solutions, and with what we are going to give those cloud computing solutions, those solutions will be given with the help of the frameworks, platforms, and infrastructure. Okay, with the help of the frameworks, platforms, and infrastructure. So these services, this creation, what it led to? It led to the infrastructures delivering the cloud services. Okay, so it is nothing but what? It is nothing but the development of application and systems. And using that, and by developing and development of application and systems. What you are going to leverage? That leverage cloud computing solutions. Okay, that leverage cloud computing solutions and the creation of frameworks. Creation of frameworks you are going to have, and platforms and infrastructures. Okay, so by how we are going to give? By providing the infrastructure, delivering the cloud computing services. That's how we are going to build the cloud computing environment. So next, how we are going to deploy the application deployment. What is mean by application deployment? So applications which are going to use that leverage cloud computing benefit, okay, that will be used for your cloud computing benefit. So from its capability to dynamically scale on demand. That means what? Whenever you are going to have the application, if you want to have the benefit of cloud computing, so what should be the feature of your application? That application should be scalable. What do you mean by scalable? So as I told you already, as and when the technology advance, technological changes happening in the society, the system has to upgrade itself. We have to update the application without stopping the without having the downtime. That means the regular work which is going on, that should go on. Okay, but whatever the technological advancement has been happened, that would be incorporated there. So that is where the main thing which you are going to have, that is it should have the capability of dynamical scale. So that means dynamical scaling should be having that particular application. So one class of applications which will take the advantage here is your web 2.0. So now what it will give, it is become the platform for developing rich and complex application. So web, if you take the web, so web has what it has become, it has become the platform for developing the rich and complex applications. You are going to have the rich and complex application. What are those applications you are going to use? So it includes the enterprise application, it includes the enterprise application, and which will be leverage the internet as the preferred channel for service delivery and user interaction. So your web has become a platform for developing the rich and complex applications. Okay, so that include enterprise applications. So the enterprise applications, it may be a CRP or ERM, that is enterprise resource planning, or CRM, so customer relationship management is there. So those will be leveraged as the internet. So there we use, they will be provided for the service delivery and user interaction. So next, when you are going to have, you should have the resource incentive applications. So another class of applications, so that is considerably gained here is what? It is represent leveraging the cloud is also termed as the resource incentive applications. Now, when it comes to the resource intensive applications, so this can be either a data intensive or compute intensive. So what do you mean by data intensive and compute intensive? So in data intensive means what? Whenever you are going to have that applications which require the data, and if that particular data is available in the far place, so that means then it will become the data intensive. So compute intensive means what? When you require, when you have the large amount of data and you have to work on that large amount of data, so which is not possible. So then you are going to have a compute intensive application. If any application requires more computational power, then it will become the compute intensive applications. So now, what is the resource intensive applications we are going to have? So now when you are going to have the resource intensive, so what you are going to have? So you are going to have the large amount of resources which has to be needed constantly for a longer duration. That means I don't have the system, but I want that particular system to be used for long duration. Now, what is the limitations I should have? So how I have to build the environment for that particular resource to be used for longer duration. Assume that 3 to 4 days continuously that particular application has to run. So now I have to pay for 3 days and I have to work continuously on that particular application for longer duration. So for example, here, what we can take is it's a scientific applications. Okay. For example, what we can take is a scientific application. So now in the scientific application, what will happen? So it requires a huge computing capacity. So it requires a huge computing capacity to perform the large scale experiments. So in a while. So at that time, it is feasible to buy the infrastructure supporting them. So at that time, what will happen? It will feasible to buy the infrastructure supporting them. So when you are going to have this type of scenario, when you are going to have this type of scenario, what you need to build, what you need to have, you need to have the cloud computing to be there, and it should be a solution. So the huge computing capacity should be there to perform large scale experiments once in a while. So during that time, I cannot invest on the infrastructure for that one. So what I need to purchase that particular resource from the cloud vendor, and I will use that one, and I am going to work and I am going to release it. So this is one scenario where you require the cloud computing. Okay, so this is when we are going to have the scientific application. So we are going to have the scientific applications. It requires huge computing facility. But whatever the scientific applications going to have, it I'm not going to make use for daily. So next, when you are going to have this cloud environment, how it will be achieved? So on-demand cloud computing provides for on-demand. So it is going to provide a solution for on-demand and dynamic scaling across the entire stack of computing. How it is achieved? So it is going to be achieved by providing methods for renting computing power, storage, and networking. So it is going to be achieved by renting the computing power, storage, and networking. So and then oftenly you are going to make use of the runtime environments. So you're going to have the runtime environments, and it is going to be designed for scalability and dynamic sizing. So other way here we are going to use this, it is going to provide the application services. Okay, so it's going to provide the application services which will mimic the behavior of desktop applications, and that are completely hosted and managed on the provider side. So you're going to have the different application service, but that application service, how it is going to behave? It is going to behave in such a way that it is running on your system only. So how it is going to be provided? So, but that particular application, where it will be running, but it will be running in the vendor side, that is the service provider side. So that is completely hosted and managed by the service provider side. So next, when it comes to the distributed building cloud environment, I should have the infrastructure and system development. So for that one, you should have the distributed computing, virtualization, service orientation, and Web 2.0. So these are the four terms which will be used to form the core technologies enabling the provision of cloud services from anywhere on the globe. So next infrastructure what you require is distributed computing. So it is foundation model for cloud computing, because already we have discussed that. So whatever, this is one of the features which the cloud is requires. So all different systems which are connected all over the globe are to be connected together. That has to be worked as a single system. So like that system you are required to have if you want to have to build the cloud environments. So next you want to have the Web 2.0 technologies. So what your Web 2.0 technology is going to provide? It is going to provide you the interface through which cloud computing services are delivered. So it will be your interface through which cloud computing services are delivered, managed, and provisioned. Okay. So next, web services have become the primary access point to cloud computing orientation. So the next, service orientation is there. So service orientation, what it is going to give? Service orientation is the underlying paradigm that defines the architecture of the cloud computing platform. So next, extension as a service, everything as a service. XSS is nothing but what? Everything as a service. That clearly underlines the central role of service orientation. That means whatever you require, whatever you want, all the things will be provided as a circuit for you. So that's provided as a service. So another important concept which you require for your cloud to build an environment is virtualization. Virtualization is another key concept that plays a fundamental role in cloud computing. So if you don't have the virtualized environment, then it will become difficult for you to access the resource from which is placed in the service provider side address, which is nothing but the distance place. So at that time, the abstraction has to be rewritten. Okay, whether they are abstraction of virtual hardware or runtime environment. So that will be managed there. So these are some of the building requirements which is required for your cloud computing environment. So for requiring the cloud computing environment, two different types, terminologies you require. One is your application development, Other is infrastructure and system development. So under application development, how we are going to build the application, you should know, and how it is going to power, how it is going to provide, how we are going to access the resources by paying it, and how we are going to develop the infrastructure. So what are the necessary infrastructure to build the cloud computing? So the necessary infrastructure which you require the system development of cloud computing is what? Distributed computing, virtualization, service orientation, and web 2.0. So this is 4 things which you require under infrastructure and system development. And even application development, it is resource intensive application and data intensive application is required. Okay. So this is what all about your service orientation, service computing, and utility service oriented computing, utility computing, and building the cloud computing environment. So any doubt now? So just go through the topic. So we have discussed about the different deployment models. So I think you are remembering the deployment models, 3: public, private, and hybrid. So next we discussed about the services provided by the cloud, that is your infrastructure, platform, and software. So after that one, you should know what are the benefits of the cloud, and you should know what is the development and the development, historical development which leads to the cloud computing. Okay, so that will be part. So anybody having any doubt till now, you can ask with respect to cloud. Either it may be a public cloud, or it may be a private cloud, or it may be a hybrid cloud. So any doubts you are going to have? Anybody having any doubt? You can ask. So next, in the next class, we are starting with the different services, technologies which they are going to build. Okay. So any doubt till now? So if you have any doubt, you can ask or ping me. So I shared you the notes and the textbook. Just go through the textbook, read it. So if you have any doubt, you can come and ask. Okay. So just in between, I will give you the surprise Google Form text where you have to take it from through your chat window only. Okay. So by next week, I am going to give you the Google Form test in the Google Form. Okay. So you have to take up the test till the portion what I have been covered. So just go through it once before you take up the test. So that will be considered for your final exam. That is final marks. For final marks, it will be considered. So if you have not, so if you don't have any doubt, we'll just wind off the class. Take care. Stay in, stay safe. Happy weekend.